I'm going to start with a little bit of a theoretical introduction to what is Rasa, what sort of systems does it make sense to build with it. So Rasa is the company. Our open source framework is Rasa open source. And then we have free but not open source software to evaluate chatbots once they're in production. And then we also have an enterprise version of it, which is how we make money. So very brief introduction to Rasa. So I'm just going to talk about what you can do with Rasa, a super brief history of NLP, and then a little bit about some of the methods we use. So state machines versus neural methods, which I'm sure y'all have heard about, the deep learning, and then some thoughts on evaluation, and then we'll do some live coding together, and we'll make a simple assistant. So the focus of Rasa is on this specific domain called task-oriented dialogue systems. And what that means is the task is something that the user wants to accomplish and that you want to help the user accomplish. And they're going to do that by talking to an automated system in a two-way conversation. So I guess you could contrast this with something like a task-oriented GUI, which is not something that people say, but that would be the visual equivalent. Rasa is built specifically for that type of task. If you want to do something like open domain, so when your person who is using the assistant can ask about literally anything and get a response that seems, coherent, we don't do that. You could technically, I guess, but it would be very difficult. So probably wouldn't recommend doing that with Rasa. So we're a framework. We're open source, so you can really customize things to work in your particular domain, or I imagine for this particular group language. And the most important thing in building a Rasa assistant that is different from other systems where you might have some pre-trained modules you're using is that you provide the examples that your system learns from. So that includes for intent, trying to say, okay, the person who's using the assistant said this, how do I classify that into a class that lets me make a further decision, right? So I might have an intent that's something like greet, and I'll provide examples of all the different ways, some of the different ways that I think people might say hello to my assistant. And then I say, okay, so I'm good at identifying these classes of things that people might say. Now, how do I want my conversations to go? So you'll use something called stories to do this, and this is a pattern of conversation flow. I'll talk about this in a little bit. Rasa is built to be highly customizable. Again, we're open source. Yes. So you can also, fork it and maintain your own branch. I mean, I wouldn't know that I'd recommend that. We move pretty quickly as a development team, but if you're willing to stick with a stable point of the fork and do your own maintenance, so have at it. And as it says, this is a video series. I'm reusing some slides. It is not a video series. We're just going to finish these slides and go into some live coding. So super brief history of NLP. NLP is natural language processing. So the field of using computers to talk to humans using or understand humans using human language rather than computer language. So way back in the 50s and 80s, the focus was really on symbolic rule-based systems. So everything was written as a rule. A lot more linguists were employed. Well, I don't know about that in raw numbers, but as a percentage, more of the people working in NLP were linguists and trained in linguistics and were handwriting these rules. And then in the 90s through the 2000s, roughly, people started counting things instead. And this is the point at which you might have heard what's his face? Sorry, it's quite early for me. So if I'm a little bit out of sorts, that would be part of it. Every time I fire a linguist, my system performance goes up. So that was part of this general era / thinking, which is that we can use statistical methods and correlations and count things like words and n-grams and characters and use that as our basis rather than rules. And starting in the 2010s, we started to use neural methods, which I would say are sort of an extension of the statistical methods. But instead of statistical modeling, we now had enough compute that deep learning was a thing that could happen. And I'm not going to go too in depth about deep learning. I'm assuming, again, most of you all have at least heard of it, have sort of a general understanding of how that works. So things like embeddings and recurrent neural networks. And when I was in grad school, the really exciting architecture was bidirectional LSTM with attention, which is a flavor of recurrent neural network. And then in 2017 and forward, we got into transformers, which is another class of neural methods. So I would say from the statistical methods onwards, we're just sort of narrowing approaches rather than completely changing paradigms as we did with the rule-based systems. So transformers, it's a very specific type of model. It was designed originally for sequence-to-sequence modeling. So there's an encoder and a decoder. And basically, instead of going over a sequence to learn it, as you would with your current neural network, you look at everything in the sequence, and you have multiple layers of that looking at everything in the sequence. Which is, today probably the architecture that people use most commonly when they're looking for new architectures. But we never dropped any of the older things, right? There's still people using statistical methods. There's still people using, bidirectional LSTM with attention, just as an example. And there's still people using rule-based systems. So this is more that we've added additional approaches, and there's been sort of like a shift in trends rather than we've immediately dropped all of the older approaches. I think it's just helpful to have some context for where these systems are coming from. So understanding text. This is the sort of general task of natural language understanding, and you'll hear it a lot. And the idea is that you have raw text, human-generated text in, and on the other side, it is machine readable. So a lot of times people will call it unstructured text, which I don't like because all text has structure because it's all human language. But there are multiple ways that you can do this. So you could use rules. For example, you could have, a big piece of text and use a regular expression to find email addresses or things that match the format of email addresses. And the big benefit of this is that you don't need pretty much any data for these approaches. You just describe what it is you're looking for in a good enough way, which is not trivial, and they can also run very fast. And they can also, they don't need to train, right? Training time is not a consideration here. The downside of rule-based approaches is they're not very flexible. So they're not very good at handling things they haven't seen before and that you haven't thought about occurring before they occur. So, benefits and drawbacks. On the neural side, you could do something like using a transformer-based model. So we've developed one called Diet, which is a multitask architecture that does both intent recognition, trying to figure out what's the general class of the thing the person said, and entity recognition, picking out, mentions of specific named entities from the text and extracting them. And that model is transformer-based. And so the downside of that is that it requires training examples, which means that you have to create and annotate those training examples. And the more like the training examples are to the actual data that you are seeing in production, the better. And if you can get the actual data that you're going to see in production and use that, that's the best. And we'll touch on that in a bit. But the benefit of using a neural approach, or these sort of machine learning-based approaches, is that they're pretty good at handling things they haven't seen before. So they'll make a guess, right? Like every time they'll make a guess. And the way that we can talk a little bit about this later if anyone has questions, but the way that we balance rules and machine learning is that we use our dialogue policies. This is all configurable, but by default, you're going to have 3 dialogue policies, and each of the guesses from those policies will be associated with a confidence score, and the policy that's the most confident wins, right? So it's there's a specific name for this type of architecture. It's too early for me to remember. But basically, everybody gets a try, and the person the model, it's like, it's me, I'm very confident that's right, that's the one you go with. So Rasa assistant, would use both, right? You'd use some rules, you'd use some neural methods for both the entity extraction and intent classification, but the neural methods are really the core of the framework. And when you're developing a system in this framework, the majority of the work is coming up with examples and organizing your classes in a way that makes sense. So I hinted at this before, deciding what to do next in the conversation. So this is the job of the dialogue policy. And dialogue policies choose what your assistant does next, given the input that it's had so far. And that doesn't just have to be responding to the user, right? It could be kicking off some custom code. It could be, doing human handoff. So sending a message to like a customer service representative and being like, hey, this person has a question for you. So historically, this was where I don't want to say all of it, but like this was the thing that people thought about a lot in dialogue systems research. And the old-timey way, I'll say, of doing that is doing it by rules. So you have a big tree of all the possible paths a conversation can take. And as people pick options, they move through the trees. So if you've ever played a video game where you have a dialogue system where you pick different things to say, and then the character you're talking to says something, and then you pick a different thing to say, but then you can go back to the top if you talk to that person again and go down the tree a different path, that's an example of a dialogue tree. It's the traditional approach. It works very well in cases where it is not important that your system is flexible, right? Your system does two things and it does them extremely well, and you know everything that somebody might want to do. The downside is they can't handle, you can't handle digressions. So if I start down the tree and I'm like, wait, but I want to talk about this thing instead, too bad, the system will fail. And also, if you've ever worked with a really large state machine like this or a really large dialogue tree with this, you will know it is very difficult to maintain and extend. It's a huge pain. So we would not recommend them for more complex systems and systems where you want your assistant to really be flexible. Neural approaches. So our approach is a transformer-based model. Again, this is one that we've developed in-house, and all these papers are out there, and also some videos if you're interested in the algorithms in more depth. So TED is our transformer enabled dialogue, I think is what that stands for. And it will pick the next turn based on the conversation so far and all the conversations it's been trained on. And the real benefit of a transformer-based model like this is that it handles digressions very naturally. So I mentioned that transformers look at everything, right? So if you think about your dialogue history being up and down, like a chat box, I don't know why dialogue history is up and down, but text is right and left, or left to right, depending on what you're writing. So if you're looking at everything over the history of a conversation, right, and you have that attention, you're not having a super high, you're not weighting things that are more recent most highly, right? If someone digresses, so they're talking about here and they change topic, okay, I can sort of guess what to do here based on the last turn, and then they change topic back again, then a transformer model will look at all of the turns and be like, well, these aren't relevant anymore. Let's go back up to what we were talking about here. So it's very flexible in that way, and it handles digressions really well. And it's, it's nice to use as a user. The downside to a neural method is that it requires training examples. So patterns of what you want a conversation to look like. And in general, the more the better, the closer they are to actual conversations that someone's had with your assistant, the better. So it's, it can be more work to build initially than a rule-based system, for sure, no question about that. But you end up with a system that's a lot more flexible and also is a lot more extensible. As long as you don't have training data that directly contradicts each other, you can just keep adding training data. So we recommend using both approaches. Rules, I would say, are useful for things like two-turn conversations. So let's say every time somebody asks if this is a bot that they're talking to, I should say, yes, it's a bot, right? Or every time someone says goodbye, I should say goodbye. So if it's just like, if X happens, then Y always happens, that's a great place for a rule. Otherwise, using the transformer-driven policy and having a lot of training examples will really help have a flexible, robust assistant. So I think this is the last slide, and then we'll get into the live coding. It was. the benefits of using this sort of hybrid system is that it really lets your users interact very naturally, which when you start to have an interface that is based on natural language, there is an assumption that it will work as well as the other types of places where people use natural language, which is talking to people. So the bar is high, right? And the benefits of using this hybrid approach, and especially using neural methods, is that it can be really flexible, right? Every single conversation that somebody has with your assistant might be unique. It won't be. Most conversations will follow the same few couple paths, but some won't. Is sort of the general way that shakes out. And it also works better the more data you have. And when I say high quality data here, I mean data that matches the distribution of the data that your assistant will see in production. And of course, the best way to know that is to look at your assistant once it's in production. So how do you make sure that conversations work? One thing I didn't mention here is by writing tests. So having a test conversation where you know that this is the pattern that it should follow and making sure that your system is doing that. But the other way is once your system's in production, manually reviewing and annotating conversations. So looking at what happened and trying to figure out, was this a good user experience? How can I change my assistant to make it better? And then adding that training data into your assistant and then retraining and redeploying. So like CID with a model. Sorry, I was just like flipping through acronyms and just having a hard time pulling out the one that I wanted. So the assumption with the Rasa assistant is that it's going to continue to change over time. We call it conversation-driven development, and the tool that I mentioned at the beginning, Rasa X, is designed for this process, right? So it helps, we're working on being able to identify the conversations that are going to have the greatest impact if you look at them and annotate them, to just sort of make things a little bit faster. I don't think that's shipped quite yet, but we've definitely talked about it before. Rod says, how does Rasa handle poor spelling or grammatical errors the way that humans do? Or that humans do, yeah. Yeah, that's a great question. So for spelling, two things. A, if people keep doing it in the same way, you can just add it to your training data and you'll be fine. Spelling errors are not random. B, the simplest way to handle this is by using a character level model. So this is a model where instead of looking at words or morpheme boundaries, you instead have a sliding window over a set number of characters, right? So if I have, if I'm looking for exactly apple, A-P-P-L-E, and there's a typo, I'm gonna have a hard time. If I'm looking for the word apple, but I'm looking at over 3 character spans, right? A-P-P-P-L-E, P-P-L-E, P-L-E, P-P-L, P-L-E. Oh, why am I doing this to myself? It's very hard to do in my head. And, I take out one of the P's, or I take out the L, right? I'm still going to have APP, right? And then there's going to be more overlap between them. So character level model will work really well for that. Cloud says intent classifier does a good job with that, especially when there are more training examples. Yes. So the more training examples, the better. And the more you sort of, add data that is representative of what people are doing, the better. Shyam says, do I need to know deep learning to start with Rasa? No. In fact, I would say the majority of our developers are software developers who have not worked with machine learning previously. And we try really hard. Like if you care, obviously you can tune it away and really mess with it to your own ends. But we've tried really hard to make it usable without that deep learning knowledge. It's just that we use it and that has implications for your development process. Abdullah says, nice to have you here. Oh, thank you. You said when you use both TED and rules, do you mean stories and rules? What if they overlap each other? Right, so that's a great question. I sort of hinted at this a little bit earlier. So rules, when a rule is triggered, it is always 100% confident, right? So I mentioned that if, all of the dialogue policies, so the rules are dialogue policy, the TED is a dialogue policy that's based on the training stories. And there's another sneaky one I didn't mention, which is memoization, which basically, if I have seen this pattern in my conversation training data, I'm going to keep following that pattern. So they all get a vote. The memoization policy, if it has seen this pattern before 100%, that has really high confidence, so that's likely to win. If a rule is triggered, if the rule's like, hey, this pattern is happening, we have to follow that, that will come first. So rules will always be the number one thing that are picked if they apply, and then memoization. And then the TED policy, because it's usually, it's trained on the stories, right? It's bounded, right? Like most of the time the confidence is not going to be one. And so that's usually the one that's picked third. And the transformer policies are really better for the things where you haven't seen this exact thing before in your training data, and people are doing things a little bit differently. So that's the answer there, if they overlap each other. If they overlap each other and are contradictory, you'll get a warning when you try to train your model, so you can go and fix that. Cool. Let's do some live coding. I'm gonna stop. One sec. I have lost the Zoom controls. Oh, there it is. Okay, sorry. I was trying to find where the stop sharing was. Let me get VS Code up real quick. And we'll start an assistant. There we go. Okay, so I already have Rasa installed. This is the command prompt, right? And it's in a Conda environment. And we have some walkthroughs on YouTube that show you how to do this. Sorry, I'm trying to remember what my Conda environment's called. I think it's called Rasa install. It was called Rasa install. Good job. So I'm currently in, hope I'm in an empty directory. Yep, I'm in an empty directory. So I am going to create a new Rasa assistant. And the way that I do that is Rasa init. So when you install Rasa with pip, it also installs a command line tool so that you can interact with Rasa in the command line. And I'm going to train an initial model as well. And this is going to take a little bit. So this creates the full directory structure that you need for your assistant, and also some basic files. And I'm just going to let it train while I sort of talk about what these are. Endpoints doesn't matter really. That's more for deployment stuff and creating endpoints. As you might have guessed, credentials also deployment stuff. Config is where you describe what your basically what sort of like puzzle pieces you're putting together for your NLU. For English, you shouldn't need to mess with this until you have your system up and running. I'm gonna guess I'm gonna get some questions about Arabic. Just gonna guess that. And I have not built an assistant in Arabic, and I don't know how I would be able to evaluate it if I did, because I don't know the language. But this is where you would make your language specific changes in the config.yaml. Let's talk to our assistant really quick so I can show you what it does, and then we'll get into the files a bit more. It's loading. Oh, it's on localhost. Sorry, if you're on Windows, there's a thing with localhost where because of the way anyway, it introduces some additional lag, which is why it'll be a tiny bit slow. So right now I'm talking to my assistant in the shell. So I'm going to start by saying hi to kick off the conversation. Hi, how are you? And this is an assistant called MoodBot. So I'm going to say that I'm really sad, and it will show me, well, it's not going to render in the command line, but It'll just say bye. No, no, you were supposed to, I'm sad. You were supposed to show me a picture of a baby tiger. There we go. So if I say I'm sad, it should show me a picture of a baby tiger. So if something like this happens, right, and I was reviewing data, at a guess, this was not annotated as the correct intent. This intent should be, mood sad, I think is the name of the intent. And instead it's been detected as bye, right, as me saying goodbye. And I think it might be because I included a smiley. But this one, I think, was detected correctly because this is my intended thing. Joel says not enough intent examples. Yeah, definitely. Could absolutely extend it. Does that help you? I'm not going to click on the picture and go look at it, but believe me when I tell you it's a baby tiger. And then the assistant just says, great, carry on. And I can also ask things that, other things. So like I can ask, are you a bot? And it should say it's a bot. And it, sure enough, it does. It says I'm a bot powered by Rasa. And then to stop the assistant, just stop. So that's the assistant that is created by default when you get going. So let's poke around in these files a little bit, and I'll talk about what's in them. So endpoints and credentials, not super important. Config, so right now the language is Arabic, the language is English, and I am not sure. So this language code here will affect some of the spacey components, and I'm not sure what spacey support for Arabic is like. Oh, nice. Mohammed says, I tried to build it for Arabic and it worked perfectly. Fabulously. Good. Sorry. One sec. Let me have a little drink of water. Good, good, good. Glad to hear it. If you did need additional customization at some point, and I wouldn't really recommend messing about with this too much until you have your assistant, like you have all your training data, and when you have, about as much training data as you're willing to add, if you want to get like a little bit of additional improvements, that's when I would consider looking at your pipeline, but you shouldn't need to mess with it too much. These are pretty reasonable defaults. And this is what's in it, and I can talk about it in a little bit greater detail, but basically there's these are the steps that your text is processed through in order to these first ones are the steps that your text is processed through in order to get it from that raw text to the machine learnable readable format. And these second ones are for how your assistant decides what to say next, right? So the dialogue policy. The memoization is the one that's like, hey, if I've seen this story before, I'm going to keep doing it. The TED policy is the machine learning based one, and the rule policy is for my rules. Yeah, and again, you don't really need to mess with this if you don't want to, but you can, right? And then the more important file in the top 4 files is this domain file. So this is just the Rasa version it was built under. This is the list of intents. So these are all the things that my assistant knows about. So that the user can say to it. So greet, goodbye, affirm, which is like yes, deny, which is like no, mood great, mood unhappy, and bot challenge. Bot challenge, we recommend you always include this. It's, is this a person? Am I talking to a bot? That sort of thing. Because you don't want to lie to people and tell them they're talking to a human when they're not. Not in the least, because your assistant probably isn't going to be as good as a human would be, and it'll be very frustrating for users. And this was the mood unhappy. It was the one that was not correctly detected in the little sample. And then responses, these are all the things that the assistant can say to the user. So if you need to, you can generate responses. I would not recommend it in general. I would recommend, writing them out, like writing out all the things you want your assistant to say. And also think about, the other thing to think about is, even if you've written out the assistant responses, are there one of those things where it would not be good to respond in that way, right? So here, one example here would be like, utter happy, right? So this is what our assistant's supposed to say if the person says, I'm feeling good. And we say, great, carry on. And if this was a response to, let's say, I mood unhappy, right? And this was incorrectly detected. you know, that could be a little bit mean. So just the things to think about when you're writing your assistants. So I'm going to say, glad to hear you're doing well, carry on. Because this way, if someone says, I'm so sad, then this response makes it a little bit clearer that, hey, there was an issue with the assistant here and we're not being intentionally mean to you, if that makes sense. Sorry, a little bit of a digression there. But anyway, this is all the things your assistant can say to your users. And then just some session config stuff. This is also where you'd have things like slots. So slots are variables that are carried over the course of your conversation. We don't have any here, but we could have like one for, let's say, if we could show a picture of a baby tiger or a baby bird and we had people pick which one they wanted, then we could have a slot called picture content, I guess. So whatever you need, you add a new intent or response or slot or entity. So we're not extracting any entities here, but maybe we could extract moods as entities. So happy, sad, angry, that sort of thing. That would also be in here. So that's these files. Models, you don't really need to worry about, but basically every time you train your assistant, so you can do that using Rasa train in the command line, it'll create a new model. I mean, it's a tar, so we can't look at it, but they'll all be in here and they'll all be saved by date and time. So they will be in order. Tests. So I mentioned that this is one of the ways that you can make sure your assistant works. So these are stories that when, well, actually, let's just do it. I'll show you what happens when I do Rasa test. So I have in here some stories that I've written where the user turns are provided and the intent. So this is going to be given to the assistant as if a user said it. I expect it to be identified with this intent, and I expect the assistant to do this in response to it. And so we have a couple here. And this just makes sure that your assistant can do what you want it to do. So I'll wait for this to finish loading and then we'll go through the results a little bit. So this is how you would evaluate your assistant and validate that your machine learning is working the way you expect it to, and that especially if you start adding intents or changing stories or adding more stories and retraining, you would expect the assistant to continue to be able to pass your tests. So we have sorry, I'm having a hard time making this line up exactly. We have a confusion matrix for each of the intents. And I mean, you can't see what they are here, but the full results are in here. And I believe it should be a nice little PNG. Emphasis on the little. So we have a confusion matrix for our intents. We have a histogram for our confidence predictions. So all of our intent predictions were very confident. This suggests to me probably we should add more training data, which I think is not a surprise to us. You sort of want a range of confidences. And then confusion matrix for the entities, but we didn't extract any entities, so it's just empty. And then none of our stories failed. So when it comes time to test your assistant, that's the way you do that, and that's what's in tests. Can I span NLU across multiple files? Yes. So that's a great question. Let's pop into the last directory, well, second to last directory, which is this data directory. So our default way that this is organized is that your NLU .yaml is all of the training data for all of your intents. So here we have an intent greet, and here's all the ways that we think somebody might say greet. I think we recommend like at least 17 to 20 examples per intent. More is better. And this is the default configuration with NLU in one file, rules in one file, and stories in one file. As long as it's in the data folder and it's a YAML file, it should be included, and we don't care a whole bunch about what the exact configuration looks like. Yeah, especially as once you get to the point where your assistant is quite large and has a lot of training data, you don't want to like scroll for 5 minutes to get to the thing that you want. So examples of saying goodbye, etc. And like deny here could have probably some more examples as well. So let's say nope or just as additional ways to say no. Make sure I save this. And I'm going to need to retrain my model for any of these changes to take effect. Somebody saying they're happy. This one, super sad, I think is what I said. I'm trying to see if there's anything here that would make sense for me to have had that, maybe this super and super stoked, possibly. Yeah. And then bot challenge. Let me add some data there. Are you a real person? So this is, you can do this by hand. You can, import data and format it correctly. It's just a basic YAML. Can I put lookup examples in a separate file if I have 10,000 entity examples? Yes. So lookup is, I mentioned that you can use rules. If you don't want to write out regular expressions that are like exactly match the string, you can have something that's called a lookup table. And yes, that should be able to be in a separate file as well. And basically it'll just create regular expressions for each of the things that you're looking up and then detect them and extract them. So the other thing I talked about were stories. This is what these look like. So the happy path is a thing that like we hope people say. This is the outcome we hope for. So we say hi, the user says hi, intent from the user. The assistant utters greet from our domain file. The user says, I'm feeling great. The assistant says, good, or glad to hear you're feeling good, I think, because we wrote this in this utterance. Sad path, etc. So we only have a couple paths here as people start to interact with the assistant. What we can do from Rasa X, I don't have a Rasa X instance running, so I'm not going to do that right now, but would be adding conversations that the assistant has had with people as training data, right? So if someone's having a conversation, it doesn't go well, then you would correct it so it does go the way that you sort of want it to go in the future, and then add that to your training data and retrain. And then the final thing, well, I guess I made a change there, I don't know where that happened, is this rules file. And again, this is sort of by convention. These folders do not have to be in this way. So here we have a simple rule. Every time somebody says goodbye, we say goodbye back. Every time someone says something that's detected as a bot challenge, we say, I'm a bot. I believe in 2. Current version, rules can only be one turn and also only use them for one turn. You don't want to have really complex rules. Believe me when I say that it gets rough to maintain very, very quickly. So that's in the data file. And again, you can rejigger these however you like. This is just sort of our default recommended. Abdul says, should I repeat an intent in all stories if it has many paths? Yes. 2 things I'm thinking about there. So one, when we train from stories, when we train from stories, it sort of happens under the hood, but we don't necessarily train just like from first to last. Instead, we sort of take chunks of those stories and move them around a little bit, just to make it easier for us to capture things that are going well. So a story doesn't have to be a full conversation from start to end. We can handle it if it's not. The other thing that you can use is checkpoints. So if you have sort of like a branch, use these sparingly, but if like every conversation is going to have a first half that's the same, but a second half that's different, right? Or you have like 3 possible ways the first half can go and 2 possible ways the second half can go. What you can do is you can create a checkpoint. This is all in the docs. I'm only focused on one window now, so I don't think I can show you very easily. But that's like, okay, get to here, checkpoint, look for all the other places where this checkpoint occurs, and then look for those stories. Again, if you ever use that, you have rebuilt a state machine, which we don't recommend. Yeah, hope that helps. Concepts to preserve the context. Yeah. Let me know if you still have a question on that. Hopefully that was helpful. Yeah, so that's the training data and the way that, fabulous. So that's the training data and the way that that is handled. And then the final thing is this actions file. So I mentioned that one of the things that your assistants can do, it can, yes, of course, respond using text, and it's the easiest thing to do. We've tried to make that really streamlined. But you can also trigger code. So the way that this would work is you'd have, from an architecture level, your assistant will run on a server. And then you have a separate server running that it will make calls to via our API. It's all open source. You can check out the more details on the API if you like in our docs, which is rasa.com/docs, I believe. I should know that off the top. Yeah, it's directly in front of me. It's right here. Yeah. So you can also have a separate server running with code, and why would there not be code on the server? You can also have a second server running and make calls to that second server from your Rasa assistant. By default, we assume you're going to use Python. We have a pretty robust Python SDK. One of our engineers has worked on a Go SDK as well. So if you're a Go person, that might be an option for you. But you can have pretty much any arbitrary code you want triggered from within the assistant. So here we just have like a little example action. I think it just it just returns some text that says action hello world. So you can make utterances from within these actions. You can have your bot do something. You can, of course, integrate with other APIs, trigger something externally. I get a lot of questions about databases and database integrations. Usually you're going to have to use some sort of action file, some sort of your action server will have to handle that integration. We do some integrations, but it's mostly to keep the history of the conversation. And it's not really designed for, customer lookup or something like that. Can I deploy a Rasa bot in Streamlit? Yeah, so Vincent Wemmerdam, who's another person on the DevRel team, has, I'm gonna pull up the link in another window, has a utility he made called Rasalit. Which is more about exploring the model, but might be a good place for you to start. Yeah. I don't know that I've seen somebody deploy like a full assistant in Streamlit. Yeah, usually, we also have a lot of integrations that I haven't really talked about here. But thinking about the integration requests that we get most often, a lot of people use Facebook Messenger. A lot of people use Microsoft Teams. A lot of people use like a little React widget on the bottom of their website, and then they integrate with that. So I have a Django tutorial for using web chat is one of the widgets. It's an open source widget for React for Rasa that we don't maintain, but one of our community members do. And also we have heard the community's feedback that they would like a Rasa maintained web chat interface, and that is something we know about. So thank you for the feedback from the community. I make no promises, but we know about it. Yeah. So that is all of the, that's basically like everything that's in the, guts, I guess, all of the stuff that's inside a Rasa assistant. If you want to really get down to brass tacks and start modifying the machine learning bits, then the first thing to do would be to, the first thing to do would be to mess with config. You can also, we are built on TensorFlow. So you can also add TensorFlow parameters, either for like specific components or project wide. So if you want to set a seed or something like that, so for additional reproducibility, you can do that. Yeah, and this pipeline configuration is very very flexible. So this is sort of like our recommended thing. But like you don't have to use a diet classifier if you don't want, right? You can use a different one. We also have a pretty good integration with Hugging Face and a lot of their language model stuff. So if you wanted to use a Hugging Face model, you would, you know, it's several steps to get there. And I would recommend thinking about the size of your container, because any model that you include in your pipeline is going to need to be contained within your container for deployment. But if that works for you, then that's another thing that you can do to modify and customize your pipeline and your yeah, usually people want to modify the NLU pipeline. You can absolutely modify the policies. It's rarer for me to see people want to change the or really customize the dialogue policies, but you definitely can. So yeah. So I think I'll leave the this code up in case anybody has any questions. If you are looking for the code in this assistant, oh, actually, one sec. Let's let's just really quickly retrain our assistant so you can see what that looks like. So we've made some changes. I'm going to beans. I'm in PowerShell. There we go. I'm going to retrain our assistant. Sorry, I've been having problems with PowerShell and Python specifically. There's some version issues. Yeah, and then when we talk with our assistant, we should see, for example, a slightly different response if we say that we're feeling sad or feeling happy. PyData Saudi says, do you have to write different answers / questions in different ways? So if you're asking, do you want to include a lot of paraphrasing in your intents? Yes, absolutely. For if you're asking about how your assistant responds, you do have, this is sort of the responses here are sort of the simplest way, but there are a lot of ways to customize your responses. So probably the simplest way is to include a slot. So right now I don't have any slots, but if I had a slot called name that I was storing my user's name in, I could include it in my responses like this. I could have random selection between multiple responses by saying something like, right, so if I have two texts under a single utterance, it'll be randomly chosen between when it's triggered. You can also have channel specific responses. So I can have like show this response on Slack and this response on Microsoft Teams, for example. Yes, if you want to do like full natural language generation, and that's going to be a little bit more involved, but there's quite a bit of flexibility in how your responses are. How do I get a benefit of a word embedding model? That's a great question. So you're going to want it as a component, a custom component. So there's a little bit of futzing you're going to need to do, depending on what it looks like. There might be a little bit of futzing you need to do to get it in the right format. And then you would, once it's, in the right place in your files and in the right format, you would just add it to your pipeline as like, obviously this is all commented out. You would need to uncomment it out. Yeah, so once it's all set up, you would just add it to your pipeline by adding the name in there. And then these do happen in order. So you would want to probably put it, probably actually one up, probably before the count vector featureizer. Yeah. So that's how you do that. Yeah, it should, hopefully it's pretty extensible. Hopefully it's pretty easy to use. I will say we do, like I mentioned, our development cycle is pretty fast. So we do tend to have a lot of minor version updates, and I'd recommend, updating when you get the chance. And we have a major version update on the way as well. So just FYI. Yeah, okay, so our model's been retrained, and let's talk to it. So we're going to do that using Rasa. Well, actually, first of all, you can see all of the commands for the command line utility with help, as you would, I don't know, maybe you wouldn't expect it. That's what I'd expect. I don't know that your expectations are the same as mine. And then if I want to talk to my assistant in the shell, I can do like so, Rasa shell. And if I want more information than I will probably need, I can add this debug tag to really see what's happening sort of down in there. As you can see, it creates a lot of terminal spam. Loading the model. The lock store, I'm just going to mention things as I see them. So the lock store is what is triggered when your assistant is waiting for your user to say something. So it's not just doing a bunch of stuff, if that makes sense. All right, so let's try this, which should be correctly identified as being sad this time. Let's see, although I made a typo, so we'll see what happened. All right, let's go all the way back up to where we said something, and then we can look through the debug log really quick. Okay, so it was locked. Tracker is the history of everything that's happened in the conversation, so that's stored by default. Slot values aren't set because I don't have any slots. Response selector is not trained because I don't have a response selector. That is a specific thing that we're not using right now. Okay, so our intent was identified as deny. So our assistants thought that we said no. Again, I made a typo here. And the confidence here is pretty low. So confidence is a value between 0 and 1. So 0.57 is pretty low. As you saw in our test, the confidence for those turns were all 100%. So because the intent was identified incorrectly, we have never told our system what to do if somebody just says no, so it doesn't know what to do. Ted predicted that we should say goodbye, so this is our transformer-based policy. No rules apply, so none of the rules were triggered. The next action was utter goodbye, right? So this was something that our system had seen before because there was an error in the MLU, but it still did something, right? Anyway, so that's, and obviously there's a lot of other stuff happening here. Hassan says, in some applications, I went to integrate a question answering system to my chatbot so it would be able to answer some domain specific questions. How should I do this integration? Good question. Stop. Is the slash backwards? Sure is. Nope, it wasn't. Okay, good. Yeah, that's a great question. So it depends on how your question answering system is configured. I would probably, if it's already built, do an action. So when I have, I might even do it as, so I guess the question is, are people going to just ask questions in the course of the, are people just going to ask questions in the course of the conversation and you want to use the question answering system to answer them? Because if yes, then I would have an intent that's like, I've detected that someone's asking a question that my question answering system can handle. And from there, I would trigger an action and then pass that text over and do whatever you need to with it. Otherwise, you can also use something called FAQs. So an FAQ is where you have a set of questions, and if you detect generally that something's in that set of questions, it's a set of questions, intents, right? Sort of like a set of intents. This is what the response selector is, by the way. It will pop down into a new model for intent classification that's choosing between the types of FAQs or response selectors that you have in there. So if you just need a way to answer a lot of questions and you don't want to provide a bunch of a bunch of stories, basically. If you are using an FAQ, one of those intents is identified, you will have an utterance that's like, hey, when, you know, an utterance that by its name, Rasa will know, okay, this intent was identified, I immediately do this, and I don't need to add a billion rules or stories to make it work. So it automates the process a little bit. Yeah. Yeah, but if you already have a system, I'd use an action. Happy to help. Hamid says, how do I avoid /start when I deploy my Rasa on Telegram? Oh, yeah. So the /start is a command that you would silently send to your Rasa assistant to have it start the conversation without the user having to say anything to start. I mean, I don't use Telegram, so I'm not super familiar with it, but if you can have like a static first turn that's like, or even like an instruction when somebody launches the assistant where it's like, hey, ask a question or something so they know what to do, then that might work. Yeah, I think it's going to really depend on Telegram, and I'm not that familiar with the platform, unfortunately. Yeah. I hope it helps. Any other questions?